In this video, we are going to go over how to develop function rules from tables of data. So there are patterns in tables and we're going to come up with a function rule for them. This is a lot like coming up with a description for a sequence, which I showed you in a previous video. The only difference, we're going to do this a little more formally with X's and Y's. Input being the X, Y being the output, but really not much different than the investigations we've done in the past. So let's check this out. We're told write a function rule for each. So a function rule again is going to describe how the inputs, the X values, relate to or get to the Y values, the outputs. So some of us will just be able to look at this table and say we go from 0 to 0, 1 to -3, 2 to -6, 3 to -9, and 4 to -12. And you might notice, what do I do to each X value to get every Y value? It appears that I'm multiplying each X value by -3. Oh, and so if I multiply each X value by -3, I'm doing -3 times each X value, and that will output my Y value. And that is your function rule. And that's it. Or if you're having a little trouble seeing that, because you might be looking at me like, Mr. Groden, I have no idea what you just did. That's fine. We can investigate the differences between every next value in each column, Y being a column and X being a column. The X values go up by 1s, so let's investigate that. So every single X value goes up by 1. And every single Y value goes down by 3, right? 0 to -3 would be a subtraction of 3. -3 to -6, down 3. -6 to -3. To -9, down 3. -9 to -12, again, -3. So another way of saying this is for every X value we go up by 1, we add -3 or subtract 3. Well, what's repeatedly adding -3? Multiplying by -3. And that is why this rule makes sense to do -3 for every 1X or -3 per X. -3 times X. Now, you always want to check to make sure that your answer is correct, and the easiest way to do that, to see if the function rule works, is to evaluate or plug in every X value to see if it gives you back the corresponding Y value. So if I plug in 0, I should get out 0. So we'll do a couple of them just to check. -3 times 0, checking the top row, is equal to 0. So our X value gave us out the corresponding Y value. We're good so far. -3 times 1. That's going to give us out -3. All right, we're in good shape so far. -3 times 2, the input. That gives us out -6. Sweet. And we can keep going. -3 times 3, -9. -3 times 4, -12. So that means our function rule is correct. There you have it, peeps. A little shortcut action of how to rock this, or if you're not quite seeing it that way, certainly use a little bit more formal detective work and always check to make sure your function rule gives you the relationship where if you plug in the X value, you get out the corresponding Y value. With all that said, let's take a look at a second example before we close this one out. So we are given a table of data. This time I put it horizontally. Just wanted to show you the information a slightly different way in case your textbook or teacher presents it this way. Your X values are giving out Y values. So these are your inputs and your outputs. So let's see what the function rule is. Well, this one, we see that we go up by 1 in the X direction each time. All right, so we're still going up by 1 every single time. And then in the Y direction, we are going up by 5 every single time. 2 to 7 is +5. 7 to 12 is +5. 12 to 17, +5. 17 to 22, +5. Figure, why not vary the voice a little bit? So if we look at this, it appears that for every 1 additional X value, we go up by 5 per 1X. Oh, so Y is 5 per X, or 5 times X. So we start out with that. But here's the thing. Let's check our answer. 5 times 0 is not 2. So right off the bat, we are not correct. So we do 5 times 0, and that equals 0. Well, how do we get from the 0 output that we got to what we want? We've got to add 2. So you're the editor here, and you're making a little change just to make sure we get to the right place that we want to arrive at. 5x plus 2, let's see if that works. Well, we know that gives us 2. Let's try the next one. 5 times 1, just checking our answer here, plus 2. 5 times 1 is 5, plus 2 is 7. Oh, that got us from 1 to 7. Let's input 2 into our function rule. 5 times 2 is 10, plus 2 is 12. Oh yeah, we're looking good. 5 times 3, the input right here, plus 2 is 17. And then 5 times 4 plus 2 is 22. So we've established that the numbers that we plug into this function do indeed, from the x values, go to the corresponding y values. So we know that this function rule is correct. Personally, if you can't see the patterns right away just by saying, what do we do to x to get y? I think this detective work of seeing how x increases and how y increases will really lead you down a nicer path of being able to develop function rules from patterns presented in tables.